I want today to be as interactive as ever because I know some of you may want to ask one or two questions, but before I'm going to go into the interactive section, I think I will first walk you through some areas and to be able to tell you again that you know your exam is going to cover uh, chapter, it's going to cover hypothesis testing, confidence interval. Of course, like I said, 60% of the final, okay, we actually revolve around hypothesis testing, confidence interval. So I will advise you to actually check, revise, what we've done in those areas. But let me just confirm to you. I show you a list of formula on Monday. Of course, that is already attached to the exam document. So the list of formula that I showed on Monday is already attached to the exam document. And not only that, I'm actually going to confirm to you that there are three tables that are attached to the exam document that you actually need in this exam. I'm going to say that again. Okay, there are three tables that are actually attached to the exam booklet, okay, that you actually need in this exam. What are these three tables? The Z table, the T table, and the chi-square table. I'm going to say that again. There are three tables that are attached to the exam. They start, I'm going to call them Z table, T table, and chi-square table. I did not attach F because the question on the quality of variances is not going to come out. Questions on hypothesis testing on the quality of variance is not going to be part of the exam. So that is why I'm not going to attach F table. You don't need F table for this exam. Once again, I'm going to tell you what I've already attached to the exam document. You do not need to bring them to the exam. Okay? You did not need to bring them to the exam. Okay? So the three tables that you need, I've already attached them. The Z table, the T table. Give me 1 second. I think I'm gonna do something right now so that now, like I said, what I've already attached to the exam document, okay, I repeat, and I thought I'm gonna see is the Z table, the T table, and the chi-square table. Okay. Somebody said, what about the table detail? Which hypothesis test to use? Of course, that one is also attached. I told you. I said, initially today I said table that have the list of formula. I show you a can somebody confirm again if you're seeing me? I think I hear something frozen from my hand.
Yeah,
Okay,
your
you're
phone's
hearing
up
me
for a
now.
while, but you're back now.
Okay, thank you so much. Now, actually, this is what I said. There's going to be a table that I show on Monday, and that very table you can see it has, different formula. But the only thing that is missing in that table is proportion and the variance. Okay, so you need to know that one on your own. Okay, now apart from that table, there's going to be a T table. There's going to be Z table. I think I'm going to share this right now. Give me 1 second. I'm going to share my whiteboard. Okay, and I need you to confirm if you see my whiteboard. So everybody see my whiteboard.
Yes.
Okay,
Yeah.
now this is it. Z, T, and the chi-squared. These are the table that you need for the exam. Z, T, chi-squared. Those are the table that I have attached. You do not need to bring them. Don't bring them to the exam. I've already attached them to the exam document. Okay? And I extract them from the back of the textbook. So what is missing? This guy is missing. If F table is missing, it means there is not going to be a question on where we're going to test for equality of variances. That's not going to be part of this final because you need F table for that. So the three table that you need is Z table, T table, and a chi-square. Of course, you need chi-square for two purposes. One, maybe you want to test hypothesis about variance, or you want to construct confidence interval about variance. But you know what? Confidence interval on variance is not going to be part of the exam. The only thing that will be part of the exam is, okay, hypothesis testing about the variance. And that is why you're going to be needing the chi-squared. Okay, hypothesis testing about variance. That is the reason why you need a chi-square table. The Z and the T, of course, those are predominant. You know, you need them for hypothesis testing of mean, proportions, for one population, for two populations, of course, anything that has to do with the mean and proportion, you need all of that. So I think I've made this clarification right now about the three tables that will be part of the exam. Okay, about the three table that will be part of the exam is what I just review right now. Before I move on, is there anyone who want to ask question before I move on? Let me read my charts. Somebody said, I thought there were no variance because no F table. No F table is for F table is used for equality of variances, not variance. When you are testing variance in two populations, that is when you need F. But since I'm not setting, since there's not going to be F, it means there's not going to be a question that's centered on equality of variances. But there will be a question that's centered on testing variance for one population where you're going to make use of the chi-square. You remember we use chi-square test in class when we focus on testing hypotheses about variance in one population. Okay, so I think I've clarified that. I think I need a question. I need somebody to ask me a question before I move on. Is there any other question? Okay, if there's no any other question, let me also say what I'm saying now is being recorded. I'm also going to publish this the way I published the other one. Okay, it's being recorded. Okay, but you know what? You will be the one that will figure out whether to use Z or T in the exam. I walk you through that on Monday. But what I want to do today is the area of the multiple choice. I've set 15 questions of multiple choice. Let me write that so that you're going to see. Not 50, 15. Do you see this guy? There's going to be 15 multiple choice questions. Multiple choice. You do not need to show your work in the multiple choice. You only need to pick your, appropriate answer. Now, let me tell you what the multiple choice is going to revolve on. 10 questions in the multiple choice will revolve around chapter 4. 10 questions. 10 questions. Chapter 4. And 5 questions. Okay, 5 questions in the multiple choice. 5 questions in the multiple choice will revolve around chapter 5 and 6. But let me tell you this. Some of you may be wondering, do I need table for chapter 5 for of these 5 questions? I'm going to talk about these 5 questions now. In the multiple choice that I mentioned right now, chapter 5 and chapter 6, they represent discrete probability distribution and continuous probability distribution. This time around, you are not going to, you don't need a table. But, you know what I will advise you to, I need you to, what if they give you question and they say, based on the understanding of what we've done in class, what distribution are we assuming? I'm going to say that again. What if they give you a question, okay, and they say, based on, you remember when in class when you are talking, how am I going to identify binomial? Oh, identify binomial if they are talking about, if they give you probability of success or probability of the characteristics of interest, and you want to figure out, maybe they ask a question, what is the probability out of 10 3 we possess, that is binomial. So what I need you to do is revisit your understanding of binomial distribution. You are not going to compute probability, but a question is, will be given, okay, and they're going to say, if you want to find this, what distribution are you going to assume? Question A is going to say, oh, binomial. Question B is going to say Poisson. Question C is going to stuff like that. Okay? Somebody text me now, do we need normal approximation to binomial? No. There is no normal approximation to binomial in the final. Like I said, today is an interactive section. You can talk by asking me questions. You can chat, okay, with me. But I will easily get you when you talk. Okay? Now, if a question is talking about, success occur at the 3rd trial. Of course, the first success occur maybe at the 3rd trial or at the 5th trial, but if they mention the first success, then you should know is geometric. What about negative binomial? It is okay. The second success occur at the 10th trial. Of course, that's going to be negative binomial. So all what I need you to do is revisit what we've done. How can you understand? I may not be able to write somebody said, can you write the discrete distribution and continuous distribution that you need to know? I may not be able to do that, but what I can tell you is revisit discrete probability distribution, not to calculate probability, but for you to be able to identify if a particular question requires the use of a particular probability. Okay, if a question is asked and it's okay, what probability are we assuming here? You just need to choose. Is it binomial? Is it Poisson? Is it negative? And so on. That's all. And another thing you need to know, make sure if you are going to compute anything at all, make sure you understand the mean, how to find the mean of each of those distributions. If I were you, what you need to write in your cheat sheet, number 1, write the mean of a binomial distribution. What is the formula for mean of a binomial distribution? Give me 1 second. I'm going to make it easy now. For binomial, you see what I'm writing? The mean in binomial is NP. Please make sure you understand that. If you identify a problem to binomial, they can ask you, what does it mean? All what you just need to do is the numbers of trial multiplied by probability of success, you are done. What about geometric? What if a question is geometric? What does it mean? It is 1 over P. What about negative binomial? What about negative binomial? What about negative binomial? The mean is R over P. Okay? What about negative binomial? The mean is that. Okay? So what about somebody said, what about formula the way I said in chapter 4? I'm currently working on chapter 5. When I'm done with chapter 5, I'm going to spend the whole time, the remaining, the largest percentage of my time on chapter 4, because I know 10 questions is coming from chapter 4. But right now, I'm telling you what you need to know about chapter 5 and 6, where 5 questions is going to be set. Now, also know the mean of the Poisson distribution. I'm revealing to you now the discrete, right? Know the mean of a Poisson distribution. If you identify a distribution to be Poisson, the mean is lambda. So what about in the continuous? There are 2 distributions that are very, very crucial in this final, as far as continuous is concerned. Number 1, gamma. Gamma. If an examiner gives you a question on gamma distribution and asks you to find the mean, of course, the mean is alpha beta. In the question, they're going to give you alpha, they're going to give you beta. All what you just need to do is to multiply them to get the mean. As far as gamma distribution is concerned, you need your calculator for this exam. You do not need tables for chapter 5 and 6. Now, another distribution in the continuous that is very, very important is beta distribution. The mean is alpha over alpha plus beta. So which means if they give you alpha and beta, and they ask you to find the mean of a beta distribution, somebody said, what is it for Poisson again? Poisson, the mean in Poisson is lambda. The mean in Poisson is lambda. The person that starts with me, the mean is lambda. Thank you too. Okay, now the beta distribution, expected value of S is alpha over alpha plus. All this you need your calculator. Whether they give you question on gamma or they give you question on beta, or what you just need is what is the formula for mean for for gamma, for beta. That's what I'm giving you now. Now I want to spend the rest of the time now on chapter 4 that will carry 10 questions, and you need your scientific calculator. I'm going to go into that right now. Give me 1 second. Let me see. Yeah, I think I'm opening that guy now. Okay, now I'm going to share my screen. Please, I need you to listen. Based on chapter 4, you've seen questions like that before in exam, I think exam 2. Now, I need you to take a look at, I'm showing you exam 2 now, so that if you take a look at this, give me 1 second. You see that this is exam 2. I published this on Canvas, the solution. Now, the way multiple choice is going to look like, okay, there will be a multiple choice that will come in 2 ways: discrete, continuous. Now you remember in class, give me 1 second. I'm actually going to make this guy so big now so that you'll be able to see. I'm actually going to start from the district. I can confirm to you now. Please listen, be focused, watch this video. At the, I'm going to publish this video. I'm recording it now. There's going to be something that look like a table like this. It's not going to, of course, it's not going to be exactly this guy. There's going to be a table like this. I need someone to confirm again if you are still hearing me clearly.
Yes.
Still hear you clearly.
Still hearing you
Can
clearly.
somebody talk? Thank you so much.
Yeah.
Thank you so much for confirming that. Now there's going to be a table like this. What are the questions? Oh my God. The likely question that you're going to see is, of course, they're going to ask you, what is the expected value of Y1? Because you know they gave you Y1 and Y2, right? They're going to ask you expected value of Y1, expected value of Y2, expected the expected value of Y1 squared, expected value of Y2 squared. They're going to ask you the expectation of the product. They're going to ask you the covariance. Now, I need you to pay attention now. I want to explain this guy again. I wanted to take a look at the table. Is someone looking at the table right now? Take a look at this table here. If you take a look at this table here, how do I get expected value of Y1? Oh, take a look at this. I want to find the expected value of Y1. What are the random variable in Y1, 0, 1, right? I'm going to use 0 to multiply this guy. And I'm going to use this guy to multiply this guy. You know, this kind of table here is 2 by 3. They could give you 3 by 3. It doesn't matter. The state space of Y1 here is 0, 1. And the state space of Y2, 0, 1, 2. Do you know that my expected value of Y1 now is going to be 0 multiplied by the total. The total is 0.76, right? Then plus 1 multiplied by 0.24. This is 0. What is 1 times 0.24? That is why that guy is the answer. You will see something like that in this final. But I want the least in this final. I want somebody who's going to have a least score to have 99. That is achievable. If you listen now, you're going to get it done. Take a look at that. Is there anybody who doesn't understand how I figure out the mean here? Is there anyone? You see the way I figure out the mean of Y1? What about the mean of Y2? Take a look at the state space of Y2 here, 0, 1, 2. Don't forget, I'm actually going to make use of this state space. I'm going to use 0 to multiply the total here, total in that row. I'm going to use 1 to multiply this guy. I'm going to use 2 to multiply. So it's going to be the expected value of Y2 now is going to be 0, 0.55 plus 1, 0.16 plus 2, 0.29. You just need your calculator. Here, 0 is just going to be 1 times that. It's going to be 0.16 plus what is 0.29? 0.29 times 2, that will be 0.58. I only need to add that 0.16, that give me 0.74. Okay, that give me 0.74. Now, and that was why when you come to finding the expected value of Y2, you see why the answer is 0.74. It's super easy. I want this final to be fun. Okay, that's super easy. Now, the next thing is, how do you find the expectation of the product? Because there's going to be a question on that too, expectation of the product. There's going to be a question on the expectation of the product. There's going to be a question of the covariance. Okay, now, expectation of the product and the covariance. Let's talk about the expectation of the product. How am I going to get the expectation of the product? I need you to take a look at this guy now. I'm going to consider 0, 0, 0, 0, multiplied by 0.38 plus 0.1 multiplied by 0.17 plus 1.0 multiplied by 0.14, okay, multiplied by 0.14, 1 multiplied by 0.02 plus 20 multiplied by 0.24 plus 21 multiplied by 0.05. You see that? That's what I'm going to do to get the expectation of the product. Okay? And in it, so that is how you're going to, and the moment you get the expectation, so if you find that, if you do that very well, expectation of the product, okay, it's actually going to give you 0.12. Okay? Now, if I get the expectation of the product, how will I get the covariance? Let me tell you this. If you want to get the covariance of y1, y2, is going to be expectation of the product minus the product of the means, which means if the expectation of the product is wrong, your covariance will be wrong. So right now, the expectation of the product that you got before minus the product of the unconditional means. But let me tell you this. In a situation where what if they say, if y1 and y2 are independent? Of course, if y1 and y2 are independent, covariance will be equal to 0. And expectation of the product will be equal to this. That is if y and x are independent. But if they are not, use the formula that I show you. Now I want to go into the calculus side. Please pay attention. In the calculus side, okay, what if they give you something like, they give you a joint? Please, I need you to listen. They give you a joint right now, and they want you to find the expectation of y1. They want you to find expectation of y2. They want you to find the expectation of the product. The same thing that they want you to find in the discrete case. Okay, but you know what you're going to do here? Before you find expectation of y1, okay, I think a shot came in. Somebody said, I can't hear. Okay, I want to confirm again. Is everyone hearing me? I need you to talk if you're hearing me.
Yes. I can hear you.
Okay, okay.
I can hear you.
Okay, thank you so much. Now, when you take a look at, if I want to figure out the expectation of y1 now, as a square in the equation, which is epsilon as the mean of y1, then I need to first get f of y1. Okay, if I want to get the expectation of y1, and what am I going to get f of y1? Okay, I'm going to get f of y1. F of y1 is going to be, okay, I'm actually going to do 2y1, you know, this, I'm going to integrate with respect to y2 using the range of y2 from 0 to 1. I will need to first get the marginal. Okay, now integrating this guy now with respect to y2, it's going to be 2y1, y2. Okay, when I have a 2y1, y2 right now, then I'm actually going to plug in 0, 1, you know, wherever I see y2. When I plug in that, that will give me 2y1. That's good. The f of y1 is also going to give me 2y1. Now, after getting that, I can now find the mean. What is the expectation of y1? Which is going to be y1 f of y1, the y1. So which is going to be 2y1, okay, y1 times 2y1, the y1. No, don't forget y1, f of y1, the y1. So y1 times 2y1, that would be 2y1 squared, the y1. Don't forget what is the range of y1, 0 to 1. When I integrate that guy now, that is going to be 2y13 divided by 3 from 0 to 1. When I plug in 1 to wherever I see y1 minus when I plug in 0, that's going to be 2 over 3. That was how this guy is 2 over 3. Is there anyone who want to ask question about how to figure out this? Is there anyone? Is there any question? Okay, so if you want to get y2, if you want to get f of expected value of y2, you also need f of y2. And don't forget, your f of y2 is going to be integral f of y1, y2, the y1 to be able to get f of y2. And you're going to use the range of y1 here. After figuring out f of y2, you are now set to obtain expected value of y2, which is going to be y2, f of y2, the y2. Please take notes. Now, because of my time, I'm actually going to move. And if you want to get the variance, you know, the variance of y1 is expected value of y1 squared minus expected value of y1 all squared. And what is the expected value of y1 squared? The expected value of y1 squared is y1 squared f of y1, the y1. Please take note. Okay. And what about the product? What about the product? In case they ask you to find the product. But let me tell you this. Please pay attention. If they wanted to find the product, expectation of the product, and if they already tell you in the question y1 and y2 are independent, okay, there are two formulas for products. Let's say they did not give you information about whether y1 and y2 are independent. If you want to find the expectation of the product, it's just going to be integral y1, y2, okay, f of y1, y2, the y, you know, you're going to have two integrals, the y1, the y2. You remember what we did in class. But in a situation where they say y1 and y2 are independent, then this is how you're going to get your product. Your product is just going to be this. Do you see that? You use this guy if you are told that y1 and y2 are independent. Because in the question, what if I indicate that? If I say, if y1 and y2 are independent, what is the expectation of the product? Expectation of the product is just going to be the product of this guy. And in a situation where y1 and y2 are independent, covariance is going to be 0. Please take note. Situation where y1 and y2 are independent, covariance is 0. Covariance in that situation, the covariance will be equal to 0. That is in a situation where they said in the question, y1 and y2 are independent. But if y1 and y2 are not independent, of course, the covariance is not going to be equal to 0. Now, I think I've just explained everything to you now. And also watch out for a question like this, where they're going to give you something like this. Linear combination. Do you see there? What is the expectation of 3y1 plus, like here now? They've already, so expectation of 3y1 plus 5y2 is going to be 3 expectation of y1 plus 5 expectation of y2. And in this question here in the linear combination, I think they've already given you, you can see, they've given you the expectation of y1 to be 40. So here I'm just going to say 3 into 40 plus 5 into, what is the expectation of y2? 65. Okay, I'm just going to compute that. Watch out for linear combination as well. But what if in a situation where they ask you the variance of the linear combination, just like question 30 here? You know, question 30 here is talking about the variance of 3y1 plus 5y2. Now, this is written as 3 squared variance of y1 plus 5 squared variance of y2. And 3 squared is going to be 9. 9 variance of y1 plus 25 variance of y2. Now, you now need to go up. They've already given you the variance of y1 and the variance of y2. Can you see here? The variance of y1 is 4. The variance of y2 is 8. So what I'm going to do here is just to do 9 into 4 plus 25 into 8. Then I'm just going to compute that. Okay, this is going to be the end of the review. But before I go, I want to say this. I have some announcement before I go. Number one announcement, the university, it is a time in the semester the university require every student to do student rating of teaching. Okay, we call it SRT. It's on the canvas. The university want to hear from you about how we professors actually handle our job, how we deliver and what we need to improve upon. So I'm going to send a message today as well regarding that in the announcement section. We call that student rating of teaching, SRT. That, the university want to hear from you about that. Now, as we're preparing for the final, or what I'm just going to tell you, believe in yourself, believe you can actually do it. But before I go into that, I first want to appreciate every one of you. I'm going to confess to you, you guys have been wonderful students, because what make professor to be great is when student listen and cooperate in class. But I want to say this is going to be one of my best class ever, since 2012 that I've started teaching at this level, because you guys cooperate with me, you guys ask questions, and you know what, and you guys provided me with feedback, which actually helped my work. But what I'm going to tell you is this. Anything in life is not easy to come by. I'm going to say that again. Anything in life is not easy to come by. And let me tell you this, it is normal that we're actually going to face challenges in life. I told you the other time, we live in a stochastic environment. We live in a probability space where different things happens in different days. To get things done in this world is not an easy task. There's always going to be challenges. But let me tell you this, and that is why I define my success as the ability to rise after many falls. Let me tell you this. There's possibility we're going to fall. The fact that you failed a statistic class before, the fact that you did not score A in a statistic class before does not mean you are not going to score A in this course. You're actually going to score A. So that depends on your determination. That depends on if you're able to watch my video on Monday, watch this video, review what I asked you to review. I can guarantee you, your minimum score in this exam is going to be 99. Never rule yourself out. Don't never say never. Don't rule yourself out in any given situation. Even though situation could be complex, okay, just take your time. Okay, that's what I used to tell myself. When situation becomes so complex, I'm actually going to confront the situation. I'm going to say, you know what? I know you are complex, but I'm actually going to simplify you. I will figure you out. And let me also tell you this. Those, I used to say this, the road to success is very narrow, and everyone want to pass through the narrow road. And that road cannot take every one of us at a time. You know, I think they about estimated 7.6 billion people in the world. All of them, they acquire resources. And because of that, there's going to be a lot of people on the road. But let me tell you this. Who are those that will go? Who are those that will wait? That question is left to every individual to answer. But let me tell you this. Let me bust your bubble. It is not everyone on the road to success that is determined. And that is the reason why those who are not determined, they're going to create way for those who are determined. And that is why I'm going to tell myself, we continue to be on the race of success until I'm classified the best in the whole world. I can be the best in the whole world. Never rule yourself out. You know what I know, what I'm going to call failure is, you know, when you stay on the ground when you fall. To me, failure is staying down, not falling down. I've fallen before. I pick myself up. There's possibility I'm still going to fall again. When I fall, I pick myself up. That is success, which I define as the ability to rise and rise after many falls. Okay, it is normal to fall in a stochastic environment. Don't forget, we live in a probabilistic space. Never rule yourself out. Review what I said you should review. My friend in economics will say, those who will get the resources are those who can stand on it for a very long time on a queue, which means you need to have the spirit of endurance. You need to have the spirit of perseverance. I'm going to say that again. You need spirit of endurance and spirit of perseverance to get going. When the going gets tough, the tough gets going. You have the high probability of being classified as being as being tough if you are able to take your time, review what we've done in this class, you know, and watch my videos. And I want to believe you're actually going to succeed. Never rule yourself out. I will be the greatest professor on earth if when we are grading the final and I can see the minimum score is 99. Let us make it happen. If it has not happened before, let us make it happen in this final. It is possible. God will help you. God will help everybody. Okay, so at this point, I'm going to say this is where I'm going to draw my curtain. I wish you very best of luck in your career. Never rule yourself out. I'm going to see you all Monday in the final, in the class. It's in person. And is there anyone who want to say something before I go? Thank you too. Thank you too. Oh, somebody said you are the best professor. Thank you so much. I really appreciate that. Thank you. Is there anyone who want to ask question before I go or want to say anything before I go? Okay. In the absence of question, okay, go to the final and blast the final and score at least 99. Minimum 99. Bye for now, everyone. See you in person in the final. Okay. Bye. Yep.